what do I have today? I have an exponential function here, e raised to the power 2x, and then a natural log here, ln 1 plus x squared. So how do we tackle a question of this form? When two functions are multiplying themselves, we consider the first function. We label the first function, let's say f of x, and this one g of x. But I'll be using u and v to make it simple. So I will label the first function u and label the next function v. So I'll say that let u be equal to e raised to the power 2x, and then let v be equal to ln 1 plus x squared. Your next step is to differentiate u with respect to x, and you differentiate v with respect to what? X. So I have du dx equals 2e raised to the power 2x. Now, what do I mean by that? If I have an exponential function and I want to differentiate it, it's very simple. If I have e raised to the power ax, then the differential of this one, when I differentiate this, the result is a e raised to the power ax. So you pick the coefficients of whatever is here, use it to multiply the whole function, raise it to the same exponent, ax. So a can be any random number. It can be a positive or a negative value. So if I have something like e raised to the power x, then the coefficients I have for x here, in front of x here, is 1. So the differential of this will still be 1 e raised to the power what? X. Since we do not write this 1, you can just say that e raised to the power x, which will give you the same thing. So if I have e raised to the power, let's say, minus 3x, then the derivative of this will give me minus 3 e raised to the power minus 3x. Very simple. Hope you got this concept. So that is what I did here. 2e raised to the power 2x. Now let's differentiate this one. So we differentiate the v with respect to x, and the result is going to give, the shortcut method is that differentiate whatever is in the bracket. When I differentiate a constant, which is 1, the result is 0. I will show you the reason why that is 0. Then when I differentiate x squared, the result is what? 2x. So I'll have 2x all divided by the same 1 plus x squared. This is the derivative of this function. I will explain that. So when I have, the reason why I said the derivative of a constant is 0, if you are familiar with this, you do not have to worry yourself about it. You can forward this part of the video. So if I have a constant 2, it is the same as 2x raised to the power 0. You know that in mathematics, anything raised to the power 0 is 1. So it's still the same. It's 2 times 1 giving me the same 2. So when I differentiate this function, I am getting 2 times 0, which is use the exponent to multiply the function and then reduce the power by 1. So this will give me what? 0. The whole result is 0. So that is why the differential of a constant is always what? 0. So now, how did I get 1 plus x squared here? There is no need for me to prove this. If this function v is equal to ln 1 plus x squared was a whole function on its own given to you to differentiate, then you don't need to go use the shortcut method. You need to show the steps using what we call the chain rule in differentiation to solve this. So I will do that for the sake of those of us who still do not understand. You can show work if you like, but there is no need. That is why I didn't show it. So let's see what we have. It was actually v equals ln 1 plus x squared. Now, to be able to differentiate this using the chain rule, if you don't know how to apply the shortcut, all you need to do is that whatever is inside the bracket, represent it with a variable. Let's assume that I'm using u. So I'll say that let u be equal to 1 plus x squared. Then the main function becomes v equals natural log of what? U. Then I'll differentiate this with respect to what? X. So du dx, when I differentiate 1, the result is what? 0. So when I differentiate x squared, the result is 2x. Then my next step is I'll differentiate ln u with respect to v. So dv du is going to give us 1 over u. So you should note that the derivative of a natural log ln u will give you 1 over u. Whatever variable is here, it will be 1 over that variable. Don't forget, you can read this online. Then we apply what we call the chain rule. So from the chain rule, we can say that because I am differentiating, looking at this function, I actually labeled it v is equal to this. So I'm differentiating v with respect to x. So it will be dv dx will be equal to the product of the two derivatives. So du dx times dv dx. So we will substitute the result into the formula. Dv dx will give us, what did we get for du dx? It was 2x. Multiplying, what did we get for dv du? Sorry, this is supposed to be dv du, not dv dx, sorry. So now I will multiply the result by dv du, 1 over u. Now dv dx will give me, this is over 1, don't forget that. So this time this time this. So this is giving me 2x all over u. But in the beginning, you said let u be equal to 1 plus x squared. That was what we said. So I'll substitute it back. U is equal to 1 plus x squared. So my dv dx is going to give me 2x all over 1 plus x squared. Now, from here, we are going to now apply what we call the product rule. So product rule says that I'm differentiating the function this with respect to this. Let's assume that y equal to the function. So in the beginning, you can say that let y be equal to this, so that you differentiate y with respect to x, so that it will be simple for me. So the y dx will give you the first variable u dv dx plus the next variable dv du dx. So this means that you pick the first function, which is u, you hold it, and then you differentiate the next function, which is this one, which is the same as v. That is what I have done. Then you sum it up with the next variable, which is the next function. Then you differentiate the first variable, which is u du dv, so du dx. So now fix the result back into this formula. So dy dx will give us what is u? U was e raised to the power 2x multiplying dv dx, and dv dx we got 2x all over 1 plus x squared. So multiplying 2x all over 1 plus x squared. Then we sum it up with v. Where is v? v is ln 1 plus x squared multiplying du dx, and du dx we got 2 exponential function 2x. Now the next thing to do is to just simplify the function. So we are having the y dx to give us 2x. Don't forget this side is over 1, so I will just use this to multiply the numerator. So 2x e raised to the power 2x all over 1 plus 2e raised to the power 2x times natural log of what? 1 plus x squared. So this is our final answer. There's nothing else you can do. You can also decide to change this into a linear function by multiplying through by the denominator 1 plus x squared to make this function linear, but it's just a waste of time. You can just leave your answer there. Now the other method is we can also differentiate the function without representing the two functions with any variable. There's no need for us to do that. It depends on what you want to do. So let's see. Let me do that. So we have the same function. How can we solve this question without representing the function this and this with any variable? So all you need to do is to remember this formula. You're supposed to know the product rule formula in mind. So the product rule formula says if you are differentiating this with respect to x, then it's simply dy dx will give you the final derivative, which is equal to hold the first function e raised to the power 2x, then differentiate the next function, apply derivative to the next function, ln 1 plus x squared. Remember, we are differentiating the function with respect to x. then add it to sum it up with what? Hold the next function, the second function, then 1 plus x squared, and then differentiate the first function e2x. So that is it. You hold the first function, or you maintain the first function, apply derivative to the second function, plus maintain the second function, apply derivative to the first function. It is the same as you saying hold u, differentiate v, plus hold v, differentiate du. It's the same thing. So now in our next step, all we need to do is to differentiate what is in the bracket. So we have dy dx is giving us e raised to the power 2x multiplying the derivative of ln 1 plus x squared. The result was 2x all over 1 plus x squared. So now I have plus ln 1 plus x squared multiplying when I differentiate this, I am getting 2e raised to the power 2x. So I am getting dy dx giving me 2x e raised to the power 2x all over 1 plus x squared plus 2e raised to the power 2x ln 1 plus x squared. So this is the result. When I look at this, I think I use only 3 steps, 1, 2, 3. And when we look at the other one, we use almost about 1, 2, 3, 4, 5, 4 to 5 steps. So this choice is yours. You decide on which one that you prefer. Thank you very much. This is the end of this video. But if you haven't subscribed to this channel yet, kindly do support this channel. My name is Daniel, and I will see you in my next video.